Hello friends, here we will discuss 5 most important problems from both and stream. This is a very important as well as very tricky topic. The concept is very much understandable here and you have to understand the concept, only then you can solve this kind of question very easily by minimal touching of pen and paper. Okay, so first of all, let's understand about the same. There is two kind of speed specifically, that is, one is boat is moving along the speed and another one boat is moving against the speed. If boat moves along the speed, boat moves along the stream, then speed of boat becomes b plus s. B is the speed of boat and s is the speed of stream, right? We will use this form. Just remember this in the similar manner, that speed of boat is b and speed of stream is s, right? And boat moves against the stream, that is b minus s. This is very common, that supposedly this is a boat and this moves and the stream flows like this direction, right? Stream flows this direction. Then it is very easy. If boat moves this direction, then boat is moving along the stream. That means whatever the basic speed of boat, this would get increased by addition of the stream speed. So boat would move definitely faster than what it can move in the still water, right? And similarly, if a boat is here, stream speed in this direction and the boat is moving this direction, that means boat is moving against the stream, right? So whatever the speed of boat is there, if it would move in the still water, obviously the speed of boat becomes less if it moves against the stream, right? Because then the speed becomes b minus s. Obviously this quantity is less than b, this quantity is less than b, and this quantity is greater than b, right? So yeah, this is it. Now moving to some different phenomena. Supposedly a boat is here, a person within it, right? This is a person. Supposedly this is a person here. Now this boat is not moving at all. I am just writing a different setup here. This is the boat, same boat, and the person here in this point, right? So the position of the person in the first boat, in the first place where the boat earlier, whatever the position of person, the position of the person gets changed by a certain difference. Now the boat is not moving at all, but the person within the boat moves slightly towards the different end, towards the other end. Now the person is moving with some speed, but the boat is still not moving. So whatever the speed of boat is absolutely depend on the frame of reference, right? So what is the frame of reference here? Supposedly the frame of reference is again the flow of water. Again the flow of water. If we can think for the time being that the speed of boat is depend upon the flow of water, that is the frame of reference in our case, only then the boat is moving to a certain distance along with the boat speed, right? If it moves along the stream, that is the b plus s would be the speed then, and if it moves against the stream, and that time the speed of boat would be b minus s, right? This is the very common thing. Now one thing you should understand, that the boat, if it's moved without considering this frame of reference, this is the frame of reference here, I am not taking this frame of reference for the time being, then what would be the case? The person is within the boat, wherever it is at the initial time, it would maybe at the same point, right? So there is no movement of the person as well as the boat. If we consider that the frame of reference is not water, or the frame of reference is something that is fixed here, right? So boat is not moving at all. That is the case one. Now the second one, that is the person in the initial node, whenever the boat is just going to start its movement, at that point wherever the person's position is there, it gets slightly changed towards the other end of the boat by walking or whatever the transport is available, he is just moving towards the other end. So that's at that point of time, person is moving towards the right hand side or the other end. Better to say one end to other end. So person is moving in this moment. Now the boat is fixed. So whatever the speed is available there, only and only the speed of the person moving within the boat. Keeping one thing in mind, that the frame of reference is still same here. There is no frame of reference, or if there is any frame of reference, that is already fixed. So there is no external flow is available there. And now I am saying that the final case here, boat is here, person is here. Again, boat is here, person is here at the same point, right? I have told you, but again, drawing a different diagram, that would be easy to understand. Flow of water is there. Now the person is not moving, person is still in the same place in both of these cases, but the boat is drifting away towards the other end. Boat is drifting away to some distance, right? So in this case, you can understand that the boat is drifting away by the stream only. There is no speed of boat available. Whatever the drifting motion is included within the boat, that is only and only for the stream speed, right? So the boat speed here is 0 and the stream is something that is s prime, right? Because the boat is just drifting away by the stream speed. There is no speed of boat available. That can be happen in any kind of scenario. That can be given in a question as well, that the boat speed is 0 but the boat is moving, or rather I am saying boat is just drifting away by the stream speed only, right? So in that case, there should not be any boat movement against the stream. If it would be, then the boat is just getting back from the initial position. That can happen. Boat is just getting backwards towards from its initial point of reference, initial position where it was actually earlier, whenever a boat is just going to start its motion. Now the boat speed just depend upon the stream speed. If boat is drifting away towards the stream speed, at that time boat speeds can be 0, but if boat wants to move against the stream, and that time boat should have some speed, and that speed definitely greater than the stream speed. Otherwise the boat would not moving forward but to backward, right? I hope this is clear to you, and that's all for the basic understanding for boats and stream concept. Now moving to the first question, and here's the first one. Hindi version is available. Just try to solve it out and let's see what is the question here. The speed of boat is that the speed of current, okay, that is 29:7. So this is the boat speed and this is the stream speed, right? So this is 29, this is 7. Now we can simply take that is downstream speed here, down, and this is up. Downstream speed, that is boat plus stream, that is 36. Boat minus stream, that is boat minus stream, that is upstream speed, that is 22. Now what it's saying, and this is speed ratio. And one thing also keep in mind that if the distance is same, speed ratio inversely proportional to time ratio. See here, downstream and upstream speed, that is 36:22. So just reduce it, that is 18:11. This is the stream speed. This is the speed ratio. Now what's the time ratio? That is just exactly reverse of the speed ratio, that is 11:18, right? And the sum total, that is the speed multiplied by time, gives the distance, that is 198. In both the case it's same. So if distance is same, speed ratio is inversely proportional to time ratio. I hope this is clear, and mathematically I have just make you understand very clearly here. Hope it's clear. Now the boat goes along with the current is in 3 hours 40 minutes. 3 hours 40 minutes, that is 3 hours 40 minutes. What does it signify? That is 180 plus 40, that is 220 minutes, right? Now okay, 220 minutes. Now this 220 minutes for with the current, along with the current. So this is along with the current, this is the time speed, this is 11 unit equivalent to 220. Obviously multiply this by 20, so this also gets multiplied by 20, that is 360 minutes. 360 minutes equivalent to 6 hours, right? So 6 hours is the answer here. It will come back in starting point, that is in 6 hours. Option D, correct one. right? Understood? Moving to the second one. Here's the second one. A man can row at a speed of 13.5 km per hour in still water. So this is the boat speed, or the boat speed, or man can row. Yeah. So this is the boat speed you can consider. This is 13.5 km per hour. And if it takes 5 times as long to row a distance upstream as to row same in the downstream. So whatever the time taken, the ratio found, it's given. That is upstream ratio downstream, that is 5:1. In respect of time ratio I am talking about. So what's the speed ratio? Obviously in upstream case the speed ratio would be less part than the downstream part. So this is 1:5, right? So upstream ratio downstream, that is the time ratio if we talk about, then this is 5:1. See, if it takes 5 times as long to row a distance upstream as to row downstream. So what's the speed ratio? That is 1:5, right? Now, then the speed of the stream in kilometer per hour. Now, this is the boat speed. So this is upstream, downstream is given. So we can find out the boat speed and stream speed as well. Now, just take this speed, that is upstream. So this is 6 divided by 2. Because this is upstream, that means what? B minus S, and this is B plus S. Though I am taking here only ratio, so whatever the form is given, if we not take the average, or if we not take, divide the both value of boat speed and stream speed, that would absolutely fine, because this is in ratio form, right? So this is 6:5 and this is 4/2. So this is, here it is 3:2. So 3:2 is the ratio of the speed of boat to stream. Now the speed of stream, so this is 13.5 km speed, that is for boat. So speed of stream we have to find out, just multiply this by 2, this is 4.5, so 9 km per hour is the stream speed, right? So option C is the correct one. Moving to next, question number 3 here for you. See, a swimmer moves from point X against a current for 10 minutes before reach point Z. Okay, so from X, this is the movement, point Z, and this is for 10 minutes. 10 minutes movement from X to Z. This is 10 minutes upstream, right? And swim back along the current for next 10 minutes and comes to point Y. Now see where the Y point comes. This is to be understood. Y can come here or Y can come here. But can you understand one thing, that both the time frame, both the time reference is same. In respect of the first set, that is from X to Z, 10 minutes it's taking, but it is against the current, right? And in the reverse note, and in the second case, he moves 10 minutes along the current to Y. So if we say that one person is moving 5 minutes to a particular direction against the current from this, and again from this point he moves 5 minutes along the current, where it would be? Definitely the distance traveled along the current for the same time reference would be more than the traveling distance in the upstream note. Okay, so this is 10 minutes against the current, whatever the distance traveled between X and Z, obviously less than YZ. This is to be understood, right? Because at the second note, he swims back along the current for the next 10 minutes. So this is along the current. Obviously B plus S is the speed. Now the constant speed, that is B plus S, and the earlier that is against the current, that is B minus S. So B minus S it is to X plus Z, X to Z, and Z to Y. Obviously Y comes somewhere before X. This is it, right? Understood? Because this is along the stream for the same time reference. Okay. And now if the distance between A and B is 50 meters, this is 50 meters. Now what it's saying, now this 10 minute for upstream, 10 minute for downstream. Now if we consider one thing, that this is B minus S, up to this is B plus S, This is also for 10 minutes and this is also for 10 minutes. If we take the difference, what would happen? The boat speed is same for both the cases, so the time difference is also same. So obviously we can just cancel it out because boat speed in both the scenario is same along the time reference as well. So only the concernable thing okay. So only the concernable thing, that is the stream speed. So here it's a stream in positive note, here it's negative note. So obviously if we take the difference, we will get twice of the stream speed for 10 minutes and this is equivalent to 50 meter. Right? Understood? Now stream speed, that is 20 to, so 2.5 kilometer per hour, right? 2.5 meter per second, right? 2.5, this is meter per second. This is meter per second. If we transform this, so 2.5 multiplied by 18 by 5, this will be 0.5. So this is 9 kilometer per hour, right? So again, option C is the correct one. Moving to next, question number 4 here on your screen. Just read it and solve it. Okay. Speed of boat is 24 km per hour in still water and the speed of stream, that is 4 km per hour. So boat speed here and stream speed. So this is 24 km per hour, this is 4 km per hour. Now just okay, so this is 6:1. If the boat takes 36 hours to go to a place and come back, then what is the distance would travel in either way? So what is the actually the length of the distance in either way? It's what it is asked. So okay, so total 36 hours it would take. Now this is the speed ratio again, right? Now we have to find out upstream and downstream part. So here it's up, here it's down. So up, that is 5, 6 minus 1, and down, that is 6 plus 1, 7. So 7 and 5 sums 12. So 12 equivalent to 36 hours, right? In any form, this is speed ratio, yeah, we can understand, but the time ratio, it would just simply reverse the ratio, not changing the sum total, that is 12. So this is 36 hours, 1 unit equivalent to 3 hours. So what would be the time taken in upstream by him, that is by the boat, that is 21 hours here, and here it's 15 hours. Satisfying? 21 plus 15, 36 hours total, right? Now what is the distance it would travel in either way? Now you can do any of the two, that is 24 multiplied by 15 or 4 multiplied. Okay, so this is not 24, just upstream and downstream speed we have to take into account. So upstream speed, now speed, and this is downstream speed. This is upstream speed 20 and 28. Now the timing, that is here it's 21 and here it's 15, right? So this is 420 and this is 280 plus 140. This is again 420. So total is 420 kilometer, right? The total distance it's talking about. Understood? Okay. So this is okay. Options is somehow missing the correct option here. Anyway, make this one correct. 420 kilometer. Option B then the correct answer. Okay. Moving to the final question of the session here. Question number 5. The speed of boat in still water is 12 km and the speed of stream, that is 3 km per hour. Now the speed of boat, that is 12 km per hour. Speed of stream, that is 3 km per hour. Now a man rows to a place at a distance of 180 km and comes back to the starting point. What is the total time taken? Okay, to complete the whole journey, right? So upstream time, upstream speed rather, we can say upstream speed that is 9 km per hour. Downstream speed, what it is? Tell me. This is 12 plus 3, 15 km per hour, right? Now, total is 180 km distance it will travel. Okay, so what is the time taken? Now, for downstream speed, this is 15 km per hour. Okay, so 180 divided by, for downstream speed, that is 15 plus 180 divided by 9. So this is 15, 150, 150 plus 30, 30, that means 2 times, this is 10 times, this is 12. 12 plus this is 20, simple. So this is 32 hours, which is the answer in our case. So option is the correct one, right? So I hope you understood all the important tips here in respect of boards and streams question, and try to solve more number of similar kind question only to minimize the time factor while you are in the actual examination scenario. Okay, so that is all for now. Thanks for watching.